Okay, here we've got a moment's question. We've got a plank. We've got someone standing on the plank. Just add some extra forces. So what have we got? We've got a reaction force at B, where it's touching our support, and we've got RD, reaction force at D. We've got the child's weight, which is 145 newtons, and we have the weight of the plank, which is 100 newtons. Right, okay, so now part A says the magnitude of the force exerted by the support on the plank at B. So that means we want to find RB. Right, now if we think in the vertical plane, I've got two forces going up, which is RB plus RD. Two forces going down, which is 145 newtons plus 100 newtons. So that's 245 newtons. Okay, they've got to be in balance because our plank is not moving up and down. It may tilt, but it's not moving up or down. Right, now, as I've got two RB and RD, I'm going to pick D as my pivot. And what that means is basically that I can ignore the force RD because it will be RD times 0. So now all I'm going to do is I'll split my forces up into anti-clockwise and clockwise. And remember, if D is our pivot, then this is clockwise and this is anti-clockwise. Okay, so anti-clockwise, I've got my 245 newtons of weight, and from D that's 1.5 meters. Of course, that's anti-clockwise. So 245 newtons, which is 1.5 meters, because they're both at the center, and we know that ED is 1.5. Right, so that's 1.5 meters, and then I've got RB, which is 3.5 meters from D. Right, so let's multiply this. 245 times 1.5, that's 367.5, is equal to 3.5 times RB, and that means that RB is equal to 105 newtons. That's part A. Okay, now part B. Well, the magnitude of the force exerted by the support on the plank at D, or reaction force D. Well, we already know that RB plus RD equals 245 newtons, because they were our vertical forces. And we now know that RB is 105. So 105 plus RD equals 245. So that means that RD is equal to 140 newtons. And that's B taken care of. Now, the child moves and stands at a different point F on the plank, and the plank is in equilibrium on the point of tilting. That's the key word about D. Right, so that means now we've got our plank. We've got a support at B and a support at D. And our child has moved position. So what have we got? We've still got the weight of the plank, which is, because it's uniform, that's in the middle. But now, if it's on the point of tilting about D, that means that it must be going in the clockwise direction. Now, there's no weight. There's no weight on this side. So to make this tilt, that means that our child must be standing over here at some point F. So we need to know the distance from D of that point. Okay. So what have we got? We're going to take our moment about D, as it's about to tilt about D, And again, we think about anti-clockwise and clockwise. Well, anti-clockwise, I'm going to have the weight of the plank, my 100 newtons, and I know that that is 1.5 meters from D. And on the other side, I've got my 145 newtons, the weight of the child, times x, which I don't know. So that means I've got 150 equals 145x. So x equals 150 over 145, which means that x is about 1.03 meters away from D. And that is part C taken care of.